which conveniently just appeared on the screen. SQL Edge to Cloud, the data platform for the modern era. So it's all yours, Anna.
Awesome. Thanks so much, Daniel. And thank you to the GroupBy team for having me on. I'm very excited. It is a little early here in Los Angeles. I don't know where everyone is joining in from today, but on the West Coast, it is about 6:30 in the morning. So I've had an early morning, but all worth it. Very excited to be here today. My name is Anna Hoffman, and I work on Microsoft's Azure data team. And for this session, I wanted to do something a little bit different from what I normally do, but hopefully it goes over well. I also have a few demos on multiple laptops, so we'll see how that goes as well. This is just a day of first, and it'll either go really well or mediocre. So anyways, we're gonna get right into it. So at the heart of it, I want to share that SQL is everywhere, from the IoT edge to your data center to public clouds. And with all these options, sometimes it's a little confusing as far as what to use when and what's going on and where the latest innovations are landing. And so today I want to spend some time talking about those things, showing you some things, telling some stories, which is a little different from maybe a typical session, and of course showing some demos. And especially for this, I've also worked with our leadership team to prepare some vision items that I am allowed to say publicly. So that will be interesting, hopefully near the end of this. One thing I wanted to make sure, I do have a video. So let me just reshare real quick because I want to make sure that the video's sound goes. Okay. So if we take a look back at the past year, everything has kind of changed and been flipped on its head. It's been a really hard year, a really challenging year. And if we think about the community, and especially how as far as digital transformation goes, in the past 12 months, companies across the globe have really been forced really to make this digital transformation in a matter of months. So today we want to talk about how data is everywhere, how SQL can be used anywhere, and how SQL really is this modern data platform that has come up to the challenge to meet the digital transformation needs of pretty much any scenario. So before we get into it, I want to take a step back in time. And I do want to acknowledge that I wasn't probably alive to where we're going back in time. But when we think about SQL Server started on desktops. Then we kind of cut our teeth as the #1 department server database. And maybe some folks listening were a part of some of this in the early SQL days. And slowly we built a reputation with enterprise due to our ease of use as well as our price performance. In 2008, we went boldly to the cloud with the first Azure SQL Platform as a Service offering. We were actually part of the front and center announcement of Microsoft Windows Azure in 2008. And a few years later, we also started embracing new operating systems. So we'll talk about Linux and containers and how that has changed the game for us to do things with things like Kubernetes. And I think over all these years, we've evolved from just a database engine to more of a data platform. We have built-in machine learning. We have support for different types of models. We support IoT scenarios for streaming and analytics at the edge. And all of this, all of the things that we're doing are tied together by a proven database that is an industry leader. We've come a long way since SQL Server started over 30 years ago. If you look at the top Fortune 100 companies, SQL Server or some form of SQL is running in 98 of those. Now, many organizations are still running SQL Server at the heart of their business, but as they've evolved, as they've grown, they've also grown to adopt some of the other offerings that we'll talk about today. And many of these innovations that we're performing in Azure Data are really to help you as customers, as a community, build better applications. And at the heart of our strategy is really to extend SQL from edge to cloud. We want to put the Microsoft SQL engine, your T-SQL skills, and all your favorite tools at the heart of where the innovation is happening. So you don't have to spend a lot of churn relearning a bunch of new things. You can just use the skills you already have. We're trying to equip you to reimagine the art of the possible. For example, imagine being able to run your SQL apps with AI capabilities and decision-making at the edge in disconnected scenarios. Imagine being able to do analytics over all your data, whether it's structured or unstructured, and stored in HDFS. How much time could you save if you could scale horizontally to easily accommodate your scaling applications without having to switch hardware or worry about any migration or upgrades? All of these things are things that we've done already today. And so today we're going to dive into what I see as the main 5 items in the SQL story of SQL from edge to cloud. And I want to tell some stories, and I want to show some demos, and I want to talk about some things for the future and how we're helping companies with their digital transformations. Now, the first thing I want to talk about is Azure SQL Edge. And Azure SQL Edge is our new SQL engine in our family of SQL database, SQL-based products. And this is bringing the full power of SQL in a very small footprint so that you can run in disconnected or semi-connected environments. I want to talk about 3M first. Now, 3M is a familiar household name. It's unusual to find a work desk, even though your work desk now is different from your work desk a year and a half ago. It's unusual to find one that doesn't include some Scotch tape or Post-it notes, which are both 3M products. 3M produces more than 60,000 products in various categories, including the N95, which has been very crucial in our fight against COVID-19. Now, the SQL team partnered with one of the US manufacturing plants in 3M corporate research to basically understand how we could help them in their manufacturing. They were trying to do predictive maintenance, but there's limited connectivity in these manufacturing plants. With Azure SQL Edge, we were able to bring the devices and put them in next to the manufacturing machines. Instead of being somewhere off-site or having connectivity issues, we were able to bring it right to the machines that we wanted to do predictive maintenance. Since Azure SQL Edge includes built-in support for things like time series, Azure Stream Analytics for streaming capabilities, and AI, we're able to not only process the data at the edge, but also make decisions and inferences using machine learning models at the edge. So you bring the whole power of SQL Server to this little tiny device, very inexpensive device that you can run on all your machines in disconnected or connected environments. Now, this is a great quote from Mike, one of their technology managers, but I thought it would be cool to take a look at another example that I've spun up. So for this scenario, we're going to, take a scenario where I work for Contoso Renewable Energy, and our business is running wind farms. So what I'm going to show you is over here. So what we have here is we have these Azure SQL Edge devices running on each of our wind turbines. And for this example, I'm just using containers to run Azure SQL Edge. And of course, we have some stuff here. But what you're seeing here is some information about what we're deploying. We're leveraging the Azure IoT Edge Hub, and we're using the Microsoft Container Registry to basically get the images for these things. And you can see that we are using Azure SQL Database Edge. Now, if I switch over to the Azure portal, I've got quite a few resources up here, but I want to show you the app that is actually using Azure SQL Edge in a sensor module. So when this loads, what we're going to be able to see is we're going to see a couple different modules, including the IoT Hub module connection string. So we can see that here we're connecting to an Azure device, specifically our Edge device, and the module is the sensor module. So we're basically going to be collecting telemetry from the various sensors so we can analyze how the sensors are performing. So here's this application. This is basically my dashboard as someone who works on monitoring the different wind turbines and their statuses. And you can see that one of my wind turbines, unit 34, is experiencing an issue. So what we can do is we can click in and run a query on this specific edge device and see some information about the device. Now, a wind turbine is meant to generate power. So immediately I'm drawn to this drop in power being generated for this specific wind turbine. Now I can see the vibration looks normal, oil temperature looks normal. I don't have access to see security items because that's not the scope of my role. Just another thing that SQL supports, has supported for a while. So mechanically, I know we're not generating enough power, so I can go and look at the environment. Now for the wind speed of the farm and the wind direction of the farm, it looks pretty normal. No big changes have happened. However, if I look at the turbine itself, everything looks pretty turbulent. It's spinning at weird speeds. It's spinning in weird directions. So maybe there's something going on that I could address. Now, what we can do is we can actually take this data in and process it using machine learning. And that's what we're going to do today. So what I've done, and I'm not going to take us through this whole experiment because that would take a while, but essentially what we're trying to do is leverage Azure machine learning and automated machine learning. And just a side note, automated machine learning is a way for us to help you figure out the best parameters and how to best fit your data to a given model. But what we want to do is we want to figure out how we should be altering the blades. So which direction should we be turning them? Do we need to do anything else to kind of help them be in the optimal place to run? So what we're going to do is try to predict when we should alter the blades so that we can avoid this turbulence and just keep with a consistent speed of the wind turbine. Hopefully that makes sense. Again, I'm not going to go through all of this, but we were very easily able to get the data and kind of start looking at it, doing our exploratory data analysis, and then we can go in to create an experiment. Now, with this experiment, we are going to create a workspace and leverage automated machine learning. And again, in this experiment, we're going to leverage some training data. We're going to try to predict if we should alter the blades or when we should alter the blades. Now, I went ahead and ran this experiment just because it takes a few minutes. And what you can see in the metrics is we're able to see some information about the experiment, see that 81% accuracy is actually really high for most machine learning models. So this is looking pretty good. We can also see in the images, we have things like the confusion matrix. So this is basically going to tell us how we perform from a true positive, true negative versus our false positive and false negative. So what we want to look at is these two numbers. So these are our true positive, true negatives and our true positives, and compare them to the false ones. So these are the ones that were incorrect. We can see that we're pretty good at predicting when we don't need to alter the blades. So that would be 0, and when we do need to alter the blades. So this is a pretty good model that we've created. And we can also see things like the ROC curve and see that over training time, the accuracy and the AUC area under the curve did improve. Now, if I go back, which I can't see the top of my screen, let's see, if we go back to here, once we have the experiment and we've modeled it, the next thing we want to do is we want to download the model, because ultimately we want to deploy this model back onto our Azure SQL Edge device and really all of our devices so we can understand and better predict when we should be altering these blades. Now, what I'm going to do is I'm going to download the model, and then I can convert the model to Onyx. Onyx is more of an open source way of storing models. It's much more consumable, and it's something that Azure SQL Edge supports. So once I have this Onyx model downloaded, I can then upload it to Azure Blob Storage. Now, I just remembered that I restarted my computer right before this. So what I'm going to do is I'm going to grab the connection string or the SAS string for this Azure Blob Storage account, and we're going to apply that model directly into the Azure SQL Edge device. Okay, so I got it. So we're going to go over here to IoT Hub, and down on the side, you can see I'm in my IoT Edge devices. And I can click on this Edge device. This is the same Edge device we've been using for this scenario. And within the IoT Edge device, I'm going to see some various information like how to connect to it. And most importantly for me here is this sensor module. So we want to check out the sensor module. And we want to go ahead and add a configuration option to leverage this Onyx model. So you can see right here, we have a place to actually add that, add the connection string. So this is the connection string to that model that we created, that Onyx model that we created and downloaded. Now I'm going to save this, and what this is going to do is it's going to immediately go and deploy it on that Azure SQL Edge device. And hopefully when we go back to our application, we're going to be able to see that things are getting back to normal. So I can come in here and I can go ahead and refresh, and it's just running all the same queries again. And sure enough, you can see that our wind turbine is starting to level out. So this is just an example of how you could use Azure SQL Edge in a disconnected scenario to not only bring in data and store data, but also process data at the edge and make decisions about data at the edge. And so I think that's a pretty powerful story for Azure SQL Edge. Now, let me see. Okay, so we talked about Azure SQL Edge, and the next thing to talk about is SQL Server 2019. Now, I'm sure you are all super familiar with this and how we continue to advance this platform as we go from the early days up into some of the current days. Now, in SQL Server 2019, we did a bunch of new things, but some of the big ones that stand out to me are data virtualization, intelligent performance, and memory optimized TimpDB. Now, these three things were really important for us, and one example of this is in SQL Server Big Data Clusters. This was really the first of its kind because we were able to remove the chasm that exists between operational data stores and analytics platforms. With things like Polybase, we enabled you to do analytics and query over all your data using T-SQL and also push down querying, which is pretty powerful. It's been quite a journey to see how customers have taken 2019 and used it to their benefit in their organizations. And one customer I like to talk about is Itaú. Now, Itaú is the largest bank in Brazil and the 10th largest bank in the world, and they specialize in finance and insurance industries. Now, their concern before SQL Server 2019 is that their infrastructure was not going to keep up with their growth, and this would affect their service level agreements or SLAs. Now, keeping your business up and running is probably something, most people listening here can relate to. Now, one example of where they had struggles is when they had to roll back an operation. Now, on average, these rollbacks were taking them 4 to 5 hours, and sometimes recovery would take as long as 40 hours. I think you guys can all agree with me that that's kind of unacceptable for a business. Itaú specifically became an early adopter of SQL Server 2019 because of the new capability, accelerated database recovery. With ADR, or accelerated database recovery, we can essentially roll back faster than you can react. So a matter of seconds, they were able to roll back. And on top of that, some of the new advancements in intelligent query processing were able to make them run 90% of their queries faster than before. And the great thing about both of these things is Itaú got faster without any code changes. And you can be sure that we're committed to continue to invest in this space to continue to help you get faster with no code changes. Now, the next thing I want to talk about is really at the bleeding edge of technology innovation. This is bringing the best of SQL, Kubernetes, and Azure to run fully managed cloud data services in customer data centers or in other data centers or in other clouds on your choice of hardware and OS. This is Azure Arc. And Azure Arc didn't just come to be one day. There were years in the making of creating this product. Just to go back in time a bit, you might have remembered hearing about something called SQL PAL, or the SQL Platform Abstraction Layer. Now, this was very important for us to come up with SQL Server on Linux, because what we were able to do is take all the points where SQL touched the Windows OS and abstract those away and modify them to touch the Linux OS. So this means we didn't have to rewrite all of SQL Server to do SQL Server on Linux. We're still using the same code base, and that's something you'll find across all of these different services. Now, by coming up with SQL Server on Linux, this then paved the way for other opportunities like running SQL in containers. Now, there are lots of reasons to run things in containers, but specifically what I want to talk about is how we took SQL Server in containers, we enhanced it, we added new things like Active Directory support, and now that you're running in containers, you can run on Kubernetes. And that really paved the way for Azure Arc, because a lot of these services, well, all of these services are running on Kubernetes. Now, what we were able to do with containers and Kubernetes and Azure Arc is bring you PaaS-like capabilities or platform as a service-like capabilities to your containers, to your Kubernetes, to your Azure Arc running what we're calling Azure SQL Managed Instance on Azure Arc or PostgreSQL Hyperscale on Azure Arc. So huge innovations happening in this space. And one example of a customer doing this is Ford. They're working on bringing Azure Arc in preview today to deliver managed database services on-prem. Now, we understand that some things just aren't going to be able to go to the cloud, or for various compliance reasons, they need to be able to span multiple clouds. And that's what we're doing with Azure Arc enabled data services. You can be in a disconnected, connected, or semi-connected space. You can take advantage of versionless SQL, which was previously only available in Azure SQL Platform as a Service offerings, but you can now get those anywhere, which allows you to really take advantage of the latest updates as they come, not every few years when a new release of SQL Server comes out. We've also taken advantage of the elastic scale capabilities, and we can help you manage the scaling on your own hardware or other clouds hardware. And finally, you can take advantage of unified management. We understand that even if you are moving to the cloud, not everything's moving at once. So this is going to give you the option to sign up for unified cloud billing and see all of your billing across all your resources in one place in the same way. So that can be big as well. Now, just a quick customer story, KPMG, most of you have probably heard of them. They have over 220,000 employees, and they specialize in professional services. Now, their Tokyo division is working on something new called Cloud Next, and this team is called Ignition, and they're building a next-gen cloud native application platform, which is called Cloud Next. Now, they want to pursue the latest technology, so they've invested in Azure Arc and the managed data services there because they want to be able to meet their customers where they are, whether it's on-prem, whether it's in their Cloud Next platform, or if it's across multi-cloud. Depending on company regulations or compliance reasons, they might have these things in different places or spread across multiple. So that's Azure Arc. The last one in what I consider the direct Azure SQL family is Azure SQL. And Azure SQL is the largest platform as a service in Azure. Again, like I mentioned at the beginning, this has been around since the beginning. And Azure SQL is not just hosting SQL Server in the cloud, but we built it from the ground up. So we'll talk about some of the innovations that we've done there. We'll talk a little bit about the deployment options. We also have a demo for this one as well. Now, when we say Azure SQL, we're really referring to 3 different offerings. And I know the session after this one goes into kind of the what to choose when topic, so I won't spend a ton of time on that, but I did want to talk about some of the options and how we were innovating. The first is SQL Server on Azure Virtual Machines. Hey, we listened to you all. You said, I just want to run SQL Server in a virtual machine in Azure, And that's what this is. It's just SQL Server. You pick the version, you pick the OS, you pick all that all the way back to SQL Server 2008 R2. And we're going to do some things to help you with things like availability. So we've recently released in preview a wizard for creating availability groups using the Azure portal for your SQL Server VMs. We're going to do other things here to help you configure your instances for success. And that's the big difference for me between infrastructure as a service and platform as a service is with IaaS, it's configurable. And with the PaaS services that we have, it's built in. So with Azure SQL Managed Instance, we always say you get the best of SQL Server with the best of a managed product, managed database. So you're going to get evergreen SQL. You're never going to worry about upgrades again. Plus, you're going to get all those instance scope capabilities that you've been using, like SQL Server Agent, maybe still using database mail, DTC, machine learning services, etc. All these things are landing in Azure SQL Managed Instance. Now with Azure SQL Database, remember, this is the first service we went to Azure with in 2008. This is where a lot of our innovation is landing first, in my opinion. And two examples I have of that are serverless and hyperscale. Now for serverless, I want to just take a brief scenario. Let's say you have an expense reporting application. Now during the week, this application is used, at varying use. And maybe at the end of the month when all the expenses are due, this app kind of gets pounded. Now on the weekends or at night, less people are doing expense reports, so no one is actually using this thing. Serverless is great for situations like this because you can set the minimum and the maximum number of vCores, and we're going to bill you only for what you use within that range. On top of that, you can choose to set an auto pause delay of, say 2 hours. So 2 hours after no one's touched the database, we actually are going to shut down SQL Server, separate the compute from the storage, and we're only going to bill you for storage at this point. So that can be huge cost savings. And there are various use cases for this. Maybe you have more of an auto scaling type of scenario where you don't know what your workload is going to be like at a given time, and you don't want to choose between over provisioning and overpaying, or under provisioning and then underperforming or getting throttled. So that's kind of a great option, and we're seeing huge adoption in the serverless space. The other side is hyperscale. And this is another one that is super interesting and very exciting because what we did is we took SQL Server apart. We took SQL Server apart, all the same pieces, but we took SQL Server apart and said, how do we architect this to be a cloud native solution? And that's what we did. We implemented a very interesting layered tiered storage system to be able to accommodate this and scale you horizontally so we can support you up to 100 terabytes. But in theory, that's just a number. There's nothing physically stopping us from going bigger than 100 terabytes. So hyperscale is a very exciting space, very innovative space, and a way how we took something that was built for on-prem and re-architected it for the cloud, but we're still using the same engine. So you're still going to get that T-SQL language. You're still going to get all the functionality you get with Azure SQL Database, but now you're also getting limitless scale. Now, before I go into the demo, there is one customer I wanted to mention, and that is Allscripts. And I like this customer because they took a phased approach to migration. We'll talk a little bit about migration, but essentially what Allscripts did is they failed over 600 virtual machines in just a few weeks using something called Azure Site Recovery. You can essentially fail over your VMs into Azure. And from there, they were now running SQL Server and Azure Virtual Machines. They started taking advantage of some of the things that the SQL IaaS extension provides. And very quickly, they started to evaluate Azure SQL Managed Instance and move some resources over there. So to me, it was a very interesting example of taking a phased approach toward migration. Now, all that being said, I have another demo on a different machine. And so we are going to try to do that. And we are going to see how it goes. So I might not be looking at the camera. I have my other computer over here, and I'm going to share my screen. Oh, I can't share while I'm sharing, so I'm going to stop sharing. And thank you guys for your patience with this. I thought it would be kind of cool to mix in a Mac demo with a with a Windows demo. So let's see. And I got booted from the meeting. Okay. Give me one moment, folks. Let me try to rejoin the meeting on my Mac.
There's still plenty of time.
Awesome. You know, you never know what's going to happen when you try to do multiple laptops. This is a first for me. Okay, looks like we are back in.
Do you need me to promote you?
I think I can share.
No, that works. Yep.
Okay.
Awesome.
I don't want this. Okay, so I'm hearing myself twice. That'll do it. Is there an echo now, or are we good? Silence. Gonna take that as a positive thing. Okay.
No echo on my end. You're all good.
Awesome. Thank you, folks. And thanks for your patience. Okay, so I want to show you all this application that I built. Some of you who might know me outside of work know that I like to go for a run every morning. So I built this very simple application with a colleague, and we've been sharing it with people, and I created an account for today, if I can type. And what this app does is it's a very simple application. It basically is able to track my run. So it tracks the steps, the distance, and a few other things about my run. And I can even go ahead and start a new workout. And so while this is running, this application is running and storing all this data locally. But when I end an application, when I end a run, we're actually going to be sending some data back and forth with a hyperscale database, which is hosting all of my users' databases or data. So what you can see here is I'm using a hyperscale database. And if we take a look at the size of this database, you can see that it's currently 13 terabytes in size, and you know it can continue to grow, and there are no issues here for that. Now, if I go back, what happens oftentimes with my application, myself included, is that some users forget to stop their workout. So you go for a run, you come back from your run, and you forget to stop your workout. So what we're working on is a machine learning model that can actually predict when you have stopped your run and update your run accordingly. Now, for demonstration purposes, I'm just going to show an example where I manually update a run that I had before to less number of steps. So I'm just going to update it for the ID of the run and update the number of steps and go ahead and run this. Now, when I update runs, when I update users' runs, when we're sending data back and forth between users' applications and our Azure SQL Hyperscale database, we want to limit the amount of data that we're having to send over the wire. For example, when this update happens, I don't want to have to update and repull all of my users' data. I just want to update and pull what the changes were. Now, a feature in SQL Server is making this easier for us to do, and that is change tracking. Now, some of you have probably heard of this. It's been around for a while. It's not a new or flashy feature necessarily, but what this allows you to do is create a change table where you track the changes, and then you can call changes from a specific version. Now, this makes it super easy to do. I don't have to go leverage some third-party tool or library or service or write my own custom code to do this. I can just kind of use the change table. And what I also find really interesting is that when I create this stored procedure that's essentially going to call the change table from a specific version and return the data I want, I can also specify how this JSON data is going to be returned, which is going to make it easier for me to just pull what I need and update my application. Now, just to take a look at an example, we can see I have the GroupBy user, which is what I'm using, and we can see the latest version is 150. So I'm going to pull the latest version, and I can't reach the button because of the screen share, but I'm going to pull the latest version, and what you're going to see is I'm only getting that latest data point, which is an update. I'm not getting the insert of the run we just stopped. I'm only getting the latest data. And so even if I go back to my application, I can update to refresh, and I can see only the blue items are items that have been recently updated. So I can see this run from yesterday was updated, and we got to limit what was sending over the wire. And as a millennial, being on my phone all the time, I'm just going to embrace it. This is really awesome because this is not only going to increase the performance of my application because I don't have to wait a long time for all the data to come down, but it's also going to help me in conserving my phone battery life, which is really just pretty much everything. So this is an example of how Azure SQL Hyperscale and the functionality that the SQL engine contains is going to help me very easily create modern applications like this iOS application that I have for tracking my workouts. Now, as you might have guessed from this very nice looking application, there are some things that I am working on improving for my users, but of course I'm doing this on a different database, but I need that database to have similar functionality, really the same functionality, but probably not all the cost that's associated with a 13 terabyte hyperscale database. So before I show you what I'm using, I wanted to show you some of the changes that I'm trying to do. So I'm going to go ahead and kick this off. So I'm using VS Code to push my results, push my updates up to GitHub. And let me just show you what I changed. So I added these two SQL scripts. We're just going in order. One, I decided that I want to start tracking temperature because I think maybe we can correlate the temperature and the performance of a given run. So all I'm doing is I'm altering the training session table to add temperature, and I'm updating that stored procedure that returns JSON to also return the temperature column. Now, if I switch back into the portal and Control Tab, I want to show you that before, when I was setting up this environment, you can see it ran the first 3 changes. Now I'm using GitHub Actions here. Here I'm using DB up so I can go incrementally with my scripts, but you could also use a DAC pack with the Azure SQL Action. Now, if I switch over to here, what I can see is that add temperature build has kicked off. But while it's kicking off, let me show you the database that I'm using for my development. I'm actually using a serverless database. And I talked briefly about this, but why this is so great is because I'm not working on this application all the time. And even when I am, I'm not necessarily always putting a heavy workload on it. So I can set the minimum, maximum number of virtual cores, and I can also enable an auto pause delay. Now, if you take a look at my metrics, what's really cool is for CPU, I'm actually only being billed for what I use. So it's not billed at a flat rate, whether or not I use it or not. And on days where I don't work on the app at all, like over the weekend, I'm not billed for the app, not billed for the CPU. I'm only going to be billed for the storage, which is much less expensive. Now, if I switch back over, I can see that this build has completed and we have added scripts 4 and 5 and applied them to our database. So that's a demo that has a lot of stuff going on as I just switch back to my other machine. Demo that has a lot of stuff going on, but hopefully shows you how, once again, you can kind of take the power that we already know from SQL and just start to take advantage of some of the latest capabilities and innovations. And myself, creating fitness applications is not the only person that is investing in this space. We have a customer called High Res Studios, and they are a leading video game developer. Maybe you've heard of them. Games like Global Agenda, Smite Paladins, Realm, Royale, and Rogue Company, or Roco. I did have to write these down. I'm not a gamer. But Roco is their latest release, and for it, they're using Azure SQL Hyperscale. Now, when gaming companies launch a game, there are a few things that are very important to them. One, they're not sure how many people are going to use the game. It could be 5 people, it could be 5 million people. So being able to scale very quickly is super important to video game developers. Also, availability is super important. Imagine playing an online game that's slow. You're not going to play for very long. So HighRes was looking for a database that gives them the full T-SQL surface area, really low read-write latency, as well as limitless scale. And that's what they got. So they were able to scale their same database from a few gigabytes to hundreds of terabytes in a matter of minutes. So this is pretty powerful, very cool to be working with gaming developers as well. Now, we talked a lot about cloud, but I haven't talked a ton about migration. So I just wanted to let you know that Microsoft is investing in the migration space as well. There are 3 main ways that we are doing that. One is with Azure Migrate. Maybe you've seen some of the recent announcements that came out in March about how we're making it easier to automatically assess and discover and recommend the exact SKU and deployment option you should go to with your SQL servers, which are currently running in VMware. We're going to continue to expand the capabilities that we have built into Azure Migrate. We are also working on inline migrations with Azure Data Studio. I tested this out for the first time last week, and it is very impressive. There is an extension that you can go get. I believe it's in private preview today, but the extension makes it very easy to step through the steps of migrating to something like Azure SQL Managed Instance. And we also have services like Azure Database Migration Service and the Log Replay Service, which are making it easier for you to migrate in the way that makes sense for your organization. Finally, I wanted to call out the data migration guides. Now, this might not be what you see as a typical investment, but to me, this is a big investment. At that URL at the top right, you can basically get a custom guide starting from source to target of what you want to migrate from, so say Oracle, to where you want to go, say Azure SQL Database, and we'll give you a step-by-step guide on how to do that. So a lot of exciting stuff happening in the Azure SQL space. I am, of course, biased because I spend a lot of time in this space, but wanted to share all that with you all. Now, if we go back to our journey, we were looking at SQL from edge to cloud. We looked at Azure SQL Edge. We looked at SQL Server 2019. We looked at this hybrid space of innovation in Azure Arc, and we looked at Azure SQL. Now, Azure Synapse is the last item that I wanted to talk about, as it is the first and only analytics system to have run all the TPC-H queries at a petabyte scale. Yeah, when I heard that, I had to read it again and go ask someone about it because I wasn't sure if that was actually a thing, and it is. And the big reason that this was made possible for Azure Synapse is because Synapse is using the same query processing engine that ships in all these other flavors of SQL. And so that's not the only thing. If we look at a customer like Grab Taxi, they're using Azure Synapse because they wanted to create a modern cloud data warehouse platform. And a big part of this, actually selecting Azure Synapse, was security. And they have to comply with local data compliance restrictions and where data goes, especially related to fine-tuning access control. So who has access to what based on how they're accessing the application and the data. Because Azure Synapse is leveraging things from SQL like native row level and column level security, combined with things like dynamic data masking, this really enabled Grab to maintain a data warehouse that was scalable and secure and helpful in creating a centralized repository of data for them to use. So this was another great customer story. Now I have something special for you all for the last 10 or 15 minutes of this. I have this video. This was actually a video we worked on creating with some animators, I don't know, a year and a half ago, but we haven't shared it very widely. So I'm going to play the video. I think it's a little inspiring. So we'll play the video. You know what? I think I didn't share my sound. So wait, let me see. You are sharing sound. Okay, so we'll play the video. It's just a few minutes. And then I want to talk to you about what we're doing in the future. So some of our future investments, what's landed, what we're still working on. Okay, so here's the video.
Imagine a tiny particle drifting at the edge of the Milky Way, a single element that could solve the next big challenge. Imagine you had the power to reach across the stars and grab it. Our world is immersed in a galaxy of data. Data that connects us, cures us, enables us to do more. Data that helps us innovate wherever imagination takes us. In 1969, Apollo 11's guidance computer was limited to 72 kilobytes as it traveled to the moon. Now, we have exponentially more power in the palm of our hands. This precious resource demands a trusted partner to harness and make every bit of it intuitively accessible at the speed of our ideas. The speed of SQL Server and Azure SQL, the latest evolution of data management's highly secure, supercharged platform, enabling you to break performance barriers and boost agility. Azure SQL Database's hyperscale capabilities allow you to auto-scale dynamically. Advanced data security keeps hazards at bay with a single click, while built-in cloud intelligence eliminates worry. Machine learning services enhance the value of your data by importing adjacent code to create models faster than ever. And with cross-platform solutions like Azure Arc, SQL Server and Azure SQL products can be leveraged virtually everywhere. Our team is motivated to consistently improve this new breed of database without disrupting the application of our existing technology. As many of the world's critical systems and most influential corporations deploy it, and agencies on our most important front lines depend on it. Businesses like Balzano that leverage SQL Server big data clusters to help radiologists interpret medical images, or Zeiss that use Azure SQL Edge to constantly improve the manufacturing of optical lenses, and organizations that help us dream bigger, like the Sloan Digital Sky Survey that built its ever-expanding database of 200 million galaxies and 260 million stars on SQL Server. Imagine what your data could dream up. Imagine unparalleled access to that next great innovation. Together, we can reach it at the speed of SQL Server in Azure SQL.
Awesome. So hopefully the audio came through for that. I do think it's a fun video. Good. I'm glad to hear that, Daniel. Awesome. Okay, so now let's talk about the future. Now, there are 5 main investment areas that I want to highlight as we talk about where we're investing and heading with SQL. The first is to unify SQL across cloud and on-prem. So the goal here is over the next few years, we want to totally blur the lines between cloud and on-prem. Azure Arc has already started to deliver on that part of the vision, but we want to go even further. As a customer, we think you shouldn't have to worry where you deploy your database. The product, the business model, and the data manageability should all be the same. So that's something we're working on. Today in Azure SQL, almost all of our production databases are protected by something called advanced threat protection. Now, you may have seen this before, but it basically allows us to use machine learning and your telemetry data to predict when some attack or vulnerability has been detected. Now, we think features like advanced threat protection should be available everywhere, not necessarily just in an Azure SQL platform as a service. And that's why over the past few months, you've seen us invest and announce Azure Defender for SQL Anywhere. Now, this means you can get that advanced threat protection capabilities on your SQL virtual machines, but also in Azure Arc, and bringing ways to get it to you in SQL Server on-prem as well. I think you'll expect things to expand like this, and things like Azure Security Center, Azure Purview, and things like Azure Defender will start to become available across different services, across the lines of cloud, on-prem, and hybrid. This is something we're working on actively with different teams, so wanted to share that. Now, whether you're going to be moving part of your workloads to the cloud or you're not going to move any workloads to the cloud, our ultimate goal is to help in bringing Azure to wherever you are. Something to keep in mind. The next investment area is around the modern developer. Now, we have today millions of customer databases. I think over 7 million databases processing over 10 trillion queries a day. But there's more work that we want to do to empower modern developers and modern applications. We want to work on supporting modern frameworks and languages, such as things like Django, Node, Angular, and Spring Data. We want to enhance our JSON and graph support in the SQL engine that's built in, so you can continue to leverage it for your needs without having to look externally or build custom code. We also have been investing in our monitoring space, and a few weeks ago, or maybe last month, we announced Azure Monitor for SQL Insights, which allows you to monitor all your databases, manage instances, and SQL VMs from one place using one service, which is pretty powerful, and we have some resources out on it, so definitely go check that out because that is available in preview today. And we want to continue to deepen our intelligence and our performance, and we want to do deeper integration with services like Azure Functions, Azure App Services, and even things like the Power Platform. So these are things to look out for and also to look into and look forward to, and give us feedback on where you want to see these investments go. Now, we've talked about hyperscale and serverless and kind of how they are kind of cutting edge and how they're changing and evolving the way we think about databases today. I didn't talk about elastic pools, but elastic pools are essentially simple, cost-effective ways of having a lot of databases that cost optimize and share resources. Now, what we want to do with Azure SQL is bring the best of hyperscale, the best of serverless, and the best of elastic pools into one service. So that's a very broad vision, but something we're working towards and something we're thinking about now. Confidential computing. You know, if you heard Bob Ward talk about the meat and potatoes of SQL Server, you know it's security, performance, and availability. In the security space, we've always been a leader in security and in this space. We're doing things like secure enclaves in SQL Server 2019, which we recently brought to Azure SQL Database for always encrypted with secure enclaves due to the hardware becoming available. We're also investing heavily and working very closely with the Azure Purview team to continue to bring you information about your data and classification and management in that space. And that final item is something that is being announced later today at Microsoft Build, but I wanted to call out that we're looking into blockchain technology and how blockchain technology can help us and help you create more secure, tamper-proof databases. And finally, I want to reiterate that SQL Server itself is very dear to our organization and our business. We don't plan to slow down with SQL Server on-prem. We don't plan to stop innovating. In the coming versions, we're going to continue to invest in security, performance, making you faster with no code changes, and availability and intelligence in those sorts of things. We continue to be transformational here. So look out in this space. We have great things planned for the future of SQL Server. Now, the last thing I really want to say is just to remind you that SQL Server started as a relation engine. And over the years, we've grown it into a fully blown data platform. As you can see, many of the innovations are not restricted to SQL Server or Azure SQL Database or Azure SQL Edge. We're taking these innovations and we're doing our best to spread them across all the deployment options as makes sense. Today, SQL powers some of the largest services in Azure, such as Azure SQL and Synapse, and they're also taking part in some key initiatives we're taking in the data space like Azure Arc, Azure Purview, and Edge. Finally, you know, we can talk tech all day, but even with the best tech innovations, no product's going to be successful without a strong community. Our philosophy has always been community-centric, and I think it shows by conferences like GroupBy, by the members we have in our community, by the hashtag SQL family. My computer just went blank. Can you all see my screen? That was weird. Sorry, guys. My computer locked. of course, in my pivotal moment of thanking you all. I apologize.
And I was speaking with my mic muted as well, but we can see you again.
Okay. Let's see. That was my last slide. So if it had just stayed put for a final second. But just to finish, I really do want to thank the community, thank the organizers, thank you for participating, thank you for taking SQL Server along this journey. We wouldn't be here without our community, without your support, without your feedback and correspondence and partnership. So I just want to encourage you all to, after today or during today, please reach out, please continue to give your feedback and support. And thank you for those folks who really support our community. Sorry for some of the technical difficulties that I've had, but thank you so much for having me today. And I hope you enjoy the rest of the GroupBy conference. I know there's a great lineup planned.